Algebra 1, 6.1, systems of equations. Consistent has at least one solution. Independent, one solution. Dependent, infinite number of solutions. So let's take a look at these three terms. All right. Consistent is going to go with independent and dependent. If something is independent, it has one solution, so it will be consistent. If something is dependent, it will also be consistent because it has an infinite number of solutions. Inconsistent is where we have no solution. So let's take a look at what this is going to look like visually. Okay? So the number of solutions, if there's exactly one solution, it will be both consistent and independent. And it will be two intersecting lines. Okay? If there is an infinite number of solutions, it will be both consistent and dependent. Notice the difference, independent and dependent. Independent has one solution, dependent will have infinite number of solutions. There are overlapping lines here. Okay, those are overlapping lines. They are called coinciding because they overlap. And there are infinite number of solutions. No solution is going to be inconsistent. They will never intersect. Okay, never intersect. Those are parallel lines. Those are parallel lines. So when we take a look at this, we have to determine what is consistent, what is inconsistent, dependent, or independent. Let's look at the lines A and B. A and B have this intersection. Because it is one point, it is considered consistent and also independent. Okay, that's A and B. A and C. If we look at A and C, we also have consistent and independent. Okay, let's take a look at B and C. Now, B and C, these are parallel lines. There are no intersections. So then that means this is inconsistent. Oops. Okay, so B and C are inconsistent. The most common you're going to have are two intersecting lines, example of AB and AC, where it'll be consistent and independent. Rarely, but will occur is when you have coinciding lines, then remember that will be consistent and dependent. And then you have B and C, parallel lines will just be inconsistent. All right, so here we have two equations, and what we want to do is solve by graphing. So we're going to graph both lines. We're going to find the intersection. So first thing we have to do is rewrite them, if we need to, in the form y equals mx plus b. That is the slope-intercept form, and that's the easiest to graph from. So in our first equation, our slope, I'm going to erase this, our slope is a -3, and our b is 10. On the second equation, we have a slope of 1, and our b is a negative 2. Okay, so first one, we have an intercept of 10, and our slope is a negative 3. So 1, 2, 3, and 1. Now, some of you might notice right away that, oh, we're counting by 2's. Well, yep, we're counting by 2's. So that 3 and 1 would be somewhere in there. So what I counted by was 6 and 2. Again, 3 and 1, 3 and 1, and that will be my line graphed through there. Like that. Okay. My other line, y is equal to x minus 2. Whoops. Intercept is a negative 2. And my slope is 1, 1. So we're going to be going through here like this. Now, one of the funny things here is that you're going to find out later is that it's not always the easiest to tell exactly where all those points are. But as you look at the problem, that intersection, it appears to be 3 for the x and 1 for the y. So our solution is 3, 1. Again, we need to rewrite these. So my top equation is going to be rewritten as a negative y equals a negative 2x minus 1. Multiply everything by a negative 1. Y is equal to 2x plus 1. Second equation, rewriting it, we'll have a negative 2y is equal to a negative 4x plus 6. Divide by a negative 2. Y is equal to 2x minus 3. Top equation, y equals 2x plus 1. My slope is 2, and my intercept is 1. Intercept is 1, slope is 2. So we have this line going through there like that. We also have the second graph, y equals 2x minus 3. The intercept is a negative 3. And the slope is 2. So we're going to go up 2 and over 1, up 2 and over 1, up 2 and over 1, up 2 and over 1. Over here, we have that. It appears we do not have an intercept. Oh, gee, Mr. Algebra, the slopes are the same. Both of them have a slope of 2. What does that mean? They are parallel or coinciding. And as you can tell from the graph, they're parallel. So we have no solution, empty set, because they're parallel. Next one. Number 3, negative y, is equal to a negative x plus 2. And this one is going to be 3y equals a negative 2x plus 9. Well, let's not do that yet. Sorry. Multiplying by a negative 1, y equals x minus 2. Second equation.
Could Mr. Johnson and Mrs. Ambrose please come to the elementary office?
Do they not know I'm trying to do a recording here? 3y is equal to a negative 2x plus 9. Divide by 3y, or divide by 3, y is equal to a negative 2/3 x plus 3. So the first equation, my slope is 1, intercept is a negative 2. So my intercept is a negative 2, and my slope is 1. Whoops. Second one, intercept is 3, and my slope is a negative 2/3. So down tune over 3, we have a double point right there. That is my intersection of these two, these two lines. So our point is 3, 1 for our answer. Okay, we have y equals a negative 2x minus 3. That one's already written in slope-intercept form. Second one, rewrite it. 3y is equal to a negative 6x minus 9. Divide everything by 3. Y is equal to a negative 2x minus 3. Do you notice that this graph or that equation and that equation are the same? That means I'm going to have coinciding lines. Coinciding lines are lines that go over the top of each other. They're the same line. So our answer, infinite number of solutions. Infinite, I think I know how to spell it by now. Infinite number of solutions. Okay, so we have an infinite number of solutions. Now remember, these are ordered pairs, so you have to be careful with doing all real numbers. Yeah, you're going to have all real numbers for x, but and then y, but not necessarily together, meaning, anyways, long story short. So infinite number of solutions there are. Let's go to the next one. Where did this come from? Oh, that's right, I rewrote it. All right, so we have soccer has 309 players and is growing by 8 per year. Track and field has 418, growing by 3 per year. When will the soccer outnumber track and field? Well, I need to write out the equations. So for soccer, we would have y is equal to our slope, our rate. Our rate is 8 per year. So that means 8x, where x is the years. And we're starting with 309. So we have 309. Y is equal to 8x plus 309. The next one, we have y is equal to, it's growing by 3 per year, so that's 3x, and we're starting at 418. All right, so in this problem, yeah, all this stuff just magically appeared. All right, so in this problem, if we put x equal to 20, okay, let x equal 20, where are those values going to be? Okay, for the top equation for the soccer team, it's going to be 469. And then for the track and field team, it'll be 478. So this is the soccer here going up, okay? And then the track and field is here. And you can see we're going to have an intersection somewhere in there. Now, next week, you're going to know how to solve this for a specific answer. You could continue to trial and error to figure out what x is exactly on this problem. I'm not worried about an exact answer in this problem because it's a graph. Later, you'll know that graph isn't always the best way to find a solution. But again, that's next week. So our answer is, if we estimate that, I would say 23 or 24 years. 23 to 24 years. But that depends on how good my graph is. It might be 25. All righty. There you are. Good luck.